In finding the derivative of trigonometric functions, we have some set of formula that we need to memorize. Here are the list of formula that we're going to use today. So we're going to use 6 formulas for the derivatives of basic trig functions. We have derivative of sine u, derivative of cosine u, and the derivative of tan u. And each of this formula, they have similar behavior. Like for this one, the derivative of sine u will be equal to cosine u du dx, wherein u is the given function or term in your derivative function, and then the du dx will be the derivative of u. So this particular rule in trigonometry, or derivatives for trigonometry, is similar to the chain rule that we had before. So we're going to use these 6 trigonometric formula for today, including the derivative of e to the u. Now, the derivative of e to the u with respect to x is simply equal to e to the u times the derivative of your exponent u, which is du dx. You will see this later on in our problems for finding the derivative of the trig functions using this formula. So we're going to start with the basic or a simple trigonometric function f of x is equal to sine 2x, and we're going to find its derivative using the formula that I showed you a while ago. Now, if you're looking with, if you're looking at sine 2x, we know from the formula that the derivative of sine is equal to cosine u du dx. So I'm showing you each of the formula that we are using for each trig functions that we're going to derive. So to further simplify or show you my work, we are going to write down u and du dx from our original function. So u from our f of x is 2x, and du dx is the derivative of u with respect to x. So the derivative of 2x is equal to 2. And these two terms is what we will need in completing our derivative for sine 2x. So f prime of x, which is the derivative of x, is equal to the cosine u du dx based from the formula sheet. And by substitution, since we already found what u is and du dx, u is 2x and du dx is 2, the derivative of the function is equal to cosine 2x times 2. So this particular function here is already our derivative, but in trigonometry we can still further simplify cosine 2x times 2, wherein our constant right here at the very end, we can place it at the very front of your function, making it 2 cosine 2x. So the derivative of f of x, which is sine 2x, is simply 2 cosine 2x. And that one is a basic derivative problem in calculus, and we're going to use this step in answering more complex trigonometric functions similar to number 2. So in number 2, we have f of x is equal to cosine 3x squared minus 1. So we know that 3x squared minus 1 is our u, and if we're going to use the formula in finding the derivative of cosine, it is simply negative sine u times the derivative of u with respect to x. So u is 3x squared minus 1, and the derivative of u with respect to x is 6x. So by plugging it into our derivative function, so f prime of x is now negative sine u du dx. By replacing u and du dx from this step right here, our derivative for cosine 3x squared minus 1 will be negative sine u is 3x squared minus 1 times du dx, which is 6x. And to further simplify this, we know that we can move 6x right here at the front, so the derivative function can be written as negative 6x sine quantity 3x squared minus 1. So this is f prime of x, or the derivative of our cosine u. And for example number 3, we'll have y equal to cosecant e raised to 3x. So here we're going to use 2 set of rules in finding the derivative of y. One is the derivative of cosecant, and the other one will be the derivative of e to the u, or e raised to 3x. So the derivative of cosecant in our formula sheet is negative cosecant u times cotangent u times du dx. Now, breaking down our function, e to the 3x will be our u, and we're going to find the derivative of e raised to 3x using the formula that we have seen on the first slide. So the derivative of e to the u is e to the u times the derivative of u with respect to x, which is simply the derivative of the exponent. So du dx will be e raised to the 3x times du dx, which is the derivative of 3x. In simplifying this function, we'll have 3e raised to 3x. So this is now our du dx, which we will use in finding the derivative of our function. So y prime, using the formula, is negative cosecant u times cotangent u times du dx. And by replacing our u and du dx from our previous work, u will be replaced by e raised to the 3x, and du dx will be replaced by 3e to the 3x. So y prime is equal to negative cosecant e to the 3x times cotangent e to the 3x times 3e raised to the 3x. And just like what we did in our previous examples, we can simplify our y prime by moving 3e to the 3x right here at the front. So it will be y prime equal to negative 3e raised to the 3x times cosecant e raised to the 3x times cotangent e raised to the 3x. And that's the derivative of problem number 3. And for number 4, we have y equal to tangent x squared minus 1. So once again, since we're using, or we are given tangent, the derivative of tangent from our formula sheet is secant squared u du dx, wherein u is x squared minus 1, and the derivative of u is 2x. And by plugging it into the derivative formula, secant squared u du dx, u is x squared minus 1, and du dx is 2x. And if you want to further simplify this derivative function, y prime is equal to 2x secant squared times x squared minus 1. Now, if you will notice, as we move on to more trigonometric functions and trying to find its derivative, it gets a little bit easier because we are now getting used to the algorithm of finding the derivative of a function given a trig identities, or similar to this one. Now for number 5, we have a rational function, and our rational function contains trigonometric functions. So we have f of x is equal to 1 plus cosine x all over sine 5x squared. And we know that when we are given a rational function or a fraction, to find its derivative, we will use low d high minus high d low all over low low, which means copying the denominator, multiplying it with the derivative of the numerator, minus copying the numerator, multiplying it with the derivative of the denominator, all over the square of the denominator. So by writing it down in our f prime of x, or finding its derivative, f prime of x will be low derivative of high minus high, which is 1 plus cosine x, times the derivative of low, which is sine 5x squared, all over sine 5x squared squared. So notice that I wrote derivative of 1 plus cosine x and the derivative of sine 5x squared, so that you will see that I am using my quotient rule in simplifying my function. So now I know that the derivative of 1 plus cosine x is simply equal to negative sine x, because the derivative of 1 is 0 and the derivative of cosine u is negative sine u du dx, so we have negative sine x. And the derivative of sine 5x squared will be cosine u times du dx, wherein u is 5x squared and the derivative of u will be 10x. So the derivative of this function is 10x times sine 5x squared. And by plugging in our derivative to our rational function, f prime of x in simplest form will be, well, it's not really the simplest form, but the derivative of f prime of x using our formula will be sine 5x squared times the derivative of this function, which is negative sine x, minus 1 plus cosine x times the derivative of this function, which is 10x cosine 5x squared, all over sine 5x squared raised to the second power. And this is the derivative of this rational function using trigonometric function.